Hello, this is Mad Arhtur, my ant-weight horizontal spinner. It currently needs quite a big upgrade on it because at the moment it's rather a hand grenade robot. Either I kill the other robot instantaneously or they kill me. So I need to make this thing a lot more reliable. With the previous versions, as you can see, they tend to rip themselves in half. There we go, see, they rip themselves in half. The main reason for this is that I've got a really heavy saw blade on here and I have no weight left inside the robot to actually do a chassis. I think this chassis weighs about 23 grams. So what I want to do is I want to take all the electronics out and replace them with the dual channel speed controller that I've been buying for my other robots and put it in here to try to reduce all this down into a much smaller package. Then I can have a smaller chassis and put a base plate on here which will strengthen up the whole thing, because at the moment that is a bit hard to see, but it is flexing even before it hits something, and the blade is hitting the top of the robot, and it's amazing this thing hasn't exploded. So I need to rebuild this chassis and try to make it stronger with some new electronics in it, and we'll see how that goes. Okay, let's see how heavy it currently weighs. 148 grams. So if we leave it as is, I've got 2 grams to put on a base plate. Ooh, no good. Okay, so yep, previous chassis weighed 22 grams, so I was wrong by 1 gram. So we'll see how much weight is in the robot once we change the speed controller. So the first thing I need to do is remove the speed controllers from the old robot and see how much weight I've got to play with when I put in the new speed controller. So I'll take these out and put in the new speed controller and see how much I've got. First thing to do is to rip out the battery, which is only held in by a bit of hot glue. Then we take out the receiver, which again, a bit of hot glue. Here it comes. Yeah, receiver with no case. And then to try to remove the speed controllers, which actually require a bit of soldering to get them out, because they're soldered into the weapon speed controller as well. And as you can see, the 2-channel speed controllers are a complete mess with all the wires. They in total weigh 15 grams. Now to put in the new speed controller, which I solder in. These things come without any wires actually attached, so you have to solder them yourself, which is kind of a pain. And it would be handy if they came pre-soldered. Okay, now to check the weight with the new speed controller soldered in. 139. So this new speed controller only saves around about 10 grams of weight. So we've got 12 grams to add a base plate and strengthen it up. Now let's see what happens when I draw it on the computer. Here's the 3D model for version 4 of the robot. I didn't actually save version 5 since it just had a few little raised ridges on the top to try to stop cracks from propagating through the model. It also has a hole in the top for the receiver to fit, which I removed. Now the first thing I want to change is to increase the gap between the saw blade and the chassis to try to stop the saw blade from hitting the chassis when it bends. So I'll start by opening up the chassis model and then saving a new copy of it so we can make a new revision. We'll be on to revision 6 for this robot. So here we go, create a new folder, new chassis number, and change the colour so it matches the 3D printing, and remove the hole for the receiver. Now when I first start drawing my robots, I start with a vertical and a horizontal layout sketch. So these are just 2 sketches that don't get actually used in the model, but they show me where all the parts are going to go. So this is the vertical layout, which has all the dimensions for where the wheels and where the motor is going to go. So I just need to adjust that so I can change the height of the motor compared to the chassis, which should update the rest of the model. Now before I get too much into the editing of the model, I better check how much this thing actually weighs according to Inventor. Now it's pretty accurate, so according to this it actually weighs 22 grams, which is the same as what we measured on the scales earlier.
so I'll pretty much take this as the actual weight when it's finished. Now the next step is to change the shape of the robot. Now because the new speed controller takes up a lot less room inside the robot, I can make the chassis a bit smaller. So what I want to do is try to narrow the front of the robot a little bit, which is going to change what the robot actually looks like. So I'm just updating the sketch here, trying to keep the wheel guards where they are and make the chassis narrower at the front. This is going to add an extra little extrusion in here, which I'm going to have to add in right now. There it is. Now most of the robot is updating itself automatically, which is pretty handy, but there is these curved wheel guards don't have a few issues, so there we go. We'll just update those little, make sure the constraints are correct. Beautiful. And then we can just pattern it over the other side, and most of it's already updated for us. Checking the weight, and we have lost 1 gram. So, well, it's not much, but basically now we have an extra 14 grams to play with. Next step is to add the mounts for the base plate. So I usually use 4 screw holes, 2 at the front, 2 at the back. So just extrude those through and pattern them onto the other side and fillet them out so they look good. Beautiful. And I need to add in a top switch, so we'll copy the dimensions from Big Yarn and make a switch exactly the same. Now the switch didn't quite fit beside the text, so I actually made the chassis an extra 5mm wider. No real reason really, but just because I can. And then update the text and the wins and losses from the last competition, which usually takes longer than drawing most other things. And now I'm copying the sketches through from the main model into a new model to create the base plate. So I copy through the sketches for the mounts and then derive those through and then project off them. That way I know that the base plate will match perfectly. I just need to put a bit of a step in the base plate so it actually goes around the chassis here, and then angle it down to the front so it matches. And add a recess so that I can still see the bolt holes for the weapon motor. Now I'm only drawing half of the base plate at the moment, and I'll just pattern it over the other side just to basically be lazy and save some work. And then add in a little gap there because that didn't quite extrude through properly, and that looks good. Now these little lugs here are actually designed to press the motors into place, so I don't need to glue the motors in anymore. Basically the base plate holds them in place, and fill it out to make it look good. Awesome. There's Cura for the models, 14.5 hours for the main chassis, and then the base plate, which is about 3.5 hours. Quite a lot of support. Now printing the cover. There's no raft on this one, so just printing straight onto the bed with the supports. I think it'll be fine. Yeah, it does look pretty good. And there it is. And now printing the main chassis. Yep, 14 hours later, and we're going to have a finished thing. There it is. Awesome. Here's the finished prints after they're being cleaned up. There's the old one. I've already put the switch in just to see if it fits. There it is. Now we just need to switch the electronics over. Now I need to explain, this is where I discovered quite a big problem. The brand new speed controller that I got is actually dead. When I try to power it up after this, the receiver powers up and the lights all blink, but the robot doesn't actually drive. Now I discussed this with the guys who sold me the speed controller, and they admitted that they gave me a dead one and they gave me a refund. But the replacement speed controller that I bought did not arrive before the competition. That means that I had to compete with the old robot, which was not fun at all. Because it turns out the old robot can't actually drive, particularly upside down. This is because the weapon axle was touching the ground and was basically acting as a wheel that was driving the robot sideways. I could get some control by making the robot turn, which actually made the robot drive sideways, but it's kind of luck if I even managed to hit the other robot. And I was basically just pretending I had control over it. It's kind of lucky I even won some fights. When the robot was this way up, the battery plug would actually lift the wheels off the ground, which would make control even worse. The robot would basically just spin in the spot and I couldn't drive forward to get off the pit. Also, the little clamp that held the saw blade onto the motor was slipping, and the motor would spin without spinning the saw blade. Basically, all I could do was really just turn the robot and hope that I could hit them. And it was kind of really luck that I even managed to win this fight too. No idea. Basically, the robot was undrivable and was no fun to even play with. It really needs that base plate to stop the electronics from touching the ground and allowing the robot to actually drive. The robot also took some damage in the fight against Tickety Boo, which was these chips in the back, as well as some damage to the wheels. Also, the saw blade was rubbing against the top of the robot, which was helping prevent it from spinning up terribly well. Okay, so I've got Mad Arhtur put back together again with the new speed controller that just arrived, and the thing now drives beautifully, which is great. However, there's been some more hiccups. One of the first was I knocked the little lug off the front that holds the nose off the ground while it's driving. It hit one of the bumps in the tiles and snapped off, so I'm going to have to glue that back on for the moment. Really, I need to reprint the whole chassis and make this little lug here a bit stronger, but I won't really do that at the moment because the other problem is the weapon speed controller had died. I believe that the wires had got frayed and have shorted out across the motor terminals. And yeah, now when I was powering it up, it was making quieter and quieter beeping noises and wouldn't turn the motor, and now it doesn't even beep. So yeah, we lost the weapon speed controller. So this thing is having really bad luck with speed controllers. The drive motor speed controller died straight out of the box, and now the weapon speed controller has died. So I've got this thing driving beautifully now, but I can't spin up at all to give it a proper test. Get out of it. At the moment I'm attempting to put this thing on the shelf and take the speed controllers and motors and everything out of it and put it into a different robot, one that doesn't have a spinner on the front, just because I'm getting kind of frustrated with this one. I do want to take it off the shelf because my first Antweights robot was a green horizontal spinner like this. So I do kind of like horizontal spinners, and I really wish I could get one going one day. But at the moment, just so much frustration with this thing. So I'll order a new speed controller online, and when it arrives, I'll put it back in here. But until then, we might build a new robot.